Hello everyone, welcome back in this JEE Advanced PYQ explanation series. So today I have picked a question which was asked in JEE Advanced 23, and the question says that I have a function f which is defined from 0 to 1 to real number set R, which is fx is equal to root of n, and it is if this condition holds. The condition is 1 by n plus 1 to 1 by n. The x should belong from where n is a natural number. And I have another function g which is defined in the same interval as the f is defined, 0 to 1 to r. And this is the inequality given for the gx, which the left hand side is the integral x squared to x, and the integrand is the square root of 1 minus t over t. And the right hand side of this inequality is a twice of root x, and is for x belongs to 0 to 1. So we have to evaluate the limit of the product of the fx and gx. So when we see the inequality, the first thing comes to our mind when we have a limit to evaluate is the Sandwich theorem. But how do we apply the Sandwich theorem? We have to understand. So first of all, let's try to understand the fx, how it is defined and what is the meaning of such definition. So I have the fx, as you can see, which is a root n. You notice the square root of n is a constant, means it doesn't depend upon the x value. The x has only this role, this much role only, which will provide the interval to define root n. But it's not a constant as a constant in each interval. It's the constant in every interval, and the interval is decided by this 1 by n plus 1 to 1 by n. So how we can say that? So let me just first define it, and I also give the idea how to apply some smart way to do it. So suppose you have x equals to 1 by n plus 1 to 1 by n given, and I'm interested to find out the first interval in which how the function look like. Let us see. So suppose I have substituted n is equal to 1. It means the first piece of the interval we will get is for x belongs to 1 over 2 close interval to 1. And in that, you can see that whatever I see in denominator of this, the right interval end, that is taken by this function. Means that is the function by which it is defined itself. It means the denominator I have is 1. It means the function will be defined for such interval is fx is equal to root of 1, that is 1. Let's take one more interval. The next interval is n is equal to 2. It means x will belong from 1 over 3 to 1 over 2. And now you notice the right end of the interval had denominator 2. It means the fx will take the definition root 2. In such, we can understand that in each such interval, which is defined like this, 1 by 2 to 1, 1 by 3 to 1 by 2, in each such interval, the function is a constant value. And this constant value is coming from the denominator of the right end and taking the root of it. So this way it is defined. If I ask you that how the function you can write in terms of x, because until we do some kind of a smart what we call manipulation to write fx in terms of x, we cannot find out the integral, limit x tends to 0 fx dx, and also this integral I have to evaluate. But how we can define the function in terms of x, let's try to understand. You can see that what I have is the x values is lying from 1 by n plus 1, which is a close there, to 1 by n. So if I do the reciprocal of it, I can say that the 1 by x will lie from n to n plus 1 closed. And now you are saying that when 1 by x, what I mean to say now, the function we are reading, when 1 by x belongs to n plus 1, the function fx is defined as n. So what is the meaning of this, Miss root n? So what is the meaning of this? The idea is that whenever I am setting this 1 by x, which is from n to n plus 1, I have to take the left end as the square root of this n value, means the under the square root, I have to take the left end of this interval. So one thing you can also understand from here, if suppose I'm taking any value between n and n plus 1, and the function is defined as root of the left end, it indicates that whenever I'm taking this 1 by x between n and n plus 1, I have to write the greatest integer of 1 by x, because this is actually the two consecutive integers, and for every 1 by x between these two consecutive integers, the function is defined at the square root of the left integer. That means the function is defined at the root of the greatest integer of 1 by x, provided one thing, that the 1 by x is not an integer. If I want to write like that, so I can say that the fx is the greatest integer of 1 by x, provided the 1 by x is not an integer. So let me write in this way, is not an integer, and will not affect. Let us see how. If I have this thing as an integer, suppose I'm substituting 1 by x as 2. So if 1 by x is 2, what is the meaning of that? This value will be here, it will become an n you are taking as 1. So let us take this as 1 by x is not an integer and see what will be the consequence, whether we can find the limit or not. So this thing we know. So we can also think in this way, that whenever I have the greatest integer and we are evaluating a limit, it's better to convert into the fraction part, so that the fraction part can be manageable under any limit, because it has interval. That the fraction part always lies between 0 and 1, so we can manage that easily. So I'm writing this greatest integer as x minus the fraction part of 1 by x, and now I have this small function, we have to use it. You notice I have this gx given with this inequality, and what this inequality is, let me just take this from here and paste it somewhere. So I have this inequality for gx, and I have to deal with that. So this is the inequality I have, and I need to find out this limit x approaches 0, the fx into gx, that limit I have to find. So why not we can multiply this entire inequality with fx each side. So I'm multiplying fx here, and x squared to x, and square root of 1 minus t by t dt. In the middle I have the gx into fx, or fx into gx, doesn't matter, and here I'm writing 2 root x into fx. Now we can impose the limit in each of the part of the inequality. So I'm writing here limit x approaches 0, here also limit x approaches 0, and here also limit x approaches 0. After this, you can notice that when we are using this inequality, and by the way, when we apply the limit, the sign will turn into the from inequality to equality also. So that thing you must know. Okay, so what I want to say that I know that if I have this value approach to some constant and this limit approach to the same constant, I can say that this value approach to the same constant, and that will be the desired limit. So let's first find this part. So I'm taking this, let's say I'm calling it the third, and I'm solving it here. This is what limit x approaches 0, and I have twice of root x, and the fx I have already found, that is the square root of the 1 by x minus the fraction part of 1 by x. You can see that both the terms I have here and here have the same, like a root is there. So we can insert this x inside the bigger root like that. Limit x approaches 0, and I have twice of. As soon as you insert this x in this root, this 1 by x will be cancelled by x, and this x will be multiplied to the fraction part of x there. So this will turn into 1 minus x into the fraction part of x. Now you notice that the fraction part of 1 by x, whatever the x value I have, this fraction part always lies between 0 and 1. There's a fixed constant between 0 and 1, and this x is approaching towards 0. It means this whole thing will approach towards 0, and so I'm getting the limit of this entire function of the third part is 2. So we got this value 2, and we save it, and we have to understand whether that the left side of the inequality is providing the same limit or not. If it provides the same limit, therefore the limit x into 0 gx fx will be 2. So now I have to deal with this left side, and I'm talking about this part, the one from here to here. Limit x tends to 0 I have now, and the fx and x squared x square root of 1 minus t, and also t there, and dt. What important thing I didn't comment on is when we are finding the limit, you can see that the function is defined from 0 to 1. So when we are finding the limit approaches towards 0, we are only finding the right hand limit. It means we are finding the limit x tends to 0 plus. So here in every limit I have written, I must write 0 plus there. By the way, it will not affect our answer, but still, as a good learner of mathematics, we must include each detail. All right. So this is the function I have now, and we are approaching this x towards 0 plus, and the function we have already defined actually. So let's see now what will be the consequence. The fx is already have square root of 1 by x minus the fraction part of 1 by x, and I have this value as it is, x squared to x square root of 1 minus t over t dt. Now think, as I have already solved the similar structure whatever I'm seeing here, which I solved here, but the only difference is here I have the support of 2 root x, or maybe more we say the precisely to find the limit, I had the support of root x, which was actually helpful to go inside the bigger root and made this x into fraction part of x 0, and this 1 remains. So from here I'm getting the motivation that why not we can make the same thing here. At this location we'll do the similar thing, but here there is no support of root x, so I'm taking the support or the help from the root x by just multiplying and dividing by it. We can do it. So we notice that the limit x tends to 0 plus, I am multiplying with root x, and this is 1 by x fraction part of x, and to compensate it, I am dividing by the same quantity. So here I'm dividing it. So what will happen, that you can see this is already we have evaluated as 1 because the 2 was multiplied to the outer side. So that's why it came as 2, but this value limit is already 1. So now I'm getting rid of this. This is 1 only, so I have to deal with the limit left over as this quantity. So let me write it, x squared to x and square root of 1 minus t over t dt by root x. Now this kind of a structure or this kind of limit you have, you might have solved in plenty of times. And why it is? Because this is 0 by 0 format in which the numerator is inviting us to apply the Leibniz formula of differentiation under the sign of integration, what we call in short the Newton-Leibniz formula. So we have to differentiate the numerator separately and denominator separately because we are applying the L'Hopital rule. So for that, I am differentiating the numerator, and for that we use the Newton-Leibniz formula, or I don't like the term, but still we'll use it. Sorry that. This is the derivative of x, that is 1, and we are substituting the x inside the function of the integrand. Sorry, that will be x here and also x here, minus the derivative of the denominator and substitute the same value in the integrand x. And in denominator also you have to differentiate, so 1 by square root of 1 by 2 times the square root of x. Now it's a clean limit question now, and we have to deal with that. Notice that limit x tends to 0 I'm writing, and I'm sending this root x in the top. So what will happen, that this will turn into root x, and this is 1 minus x over root x by splitting this, minus here I'm writing this 2x, and this is square root of 1 minus x square by square root of, this will be x square, by the way, I did a mistake in writing, and that will become mod x. The mod x I'm writing because I'm taking the square root of this, but notice x is always positive because we are approaching towards 0 from the positive side, so we never be in the domain of x less than 0. So mod x will be only x, so I can write this mod x as x only. So I'm writing this is only x, and this x and this x will cancel. Again, this root x and root x will get cancelled. Now you notice why I have to substitute the value x there, but one thing I multiplied this, when I sent this root x to the top, I multiplied to the first term, I didn't multiply here, so I have to be very careful in calculation. I must write this root x there. So now I'm left with that limit x tends to 0 plus this 2 will go there. This is already cancelled, and we can now substitute 0 safely, so that will become 1. And since this is already cancelled, I have 2 root x into this. So when x equal to 0 there, that will remain 1, but this root x will make everything 0. So I'm getting the same limit 2 on the left part also. So I got the left limit, left function limit is also 2, right function limit also 2. Therefore, what is sandwiched between them, that will also lead us to the limit 2. It means the answer we have is limit x tends to 0 plus the fx into gx is equal to 2, or limit x tends to 0. One more important thing I want to convey here is to evaluate the integral over here. I'm not going to solve it in that way because it's lengthy, But here we can evaluate the integration by just our regular process. Like if we substitute t is equal to cos theta, you can see 1 minus cos theta by cos theta, and we turn into that all the trigonometric transformations and integration, we can also get the answer. And one more thing is that maybe some students may get confused that we are not using the fullest definition of, or the what we call the formal or official definition of the greatest integer. But since the function fx is defined in such a way that is only taking the left end of the interval where 1 by x lying, we can use this definition of the greatest integer to make our life easier. Alright, so this is the take of mine on this question. See you in the next video with some other JEE Advanced question in the series what we have named it, the why behind what. Stay math active.